Okay, so we're going to start talking about ions in aqueous solutions. And the first thing we're going to talk about is dissociation. And dissociation is the separation of ions that occurs when an ionic compound dissolves. So, for example, we're going to give you 1 mole of NaCl. We're always going to dissolve a solid. And water is always our catalyst. So if I dissociate this and break this up, I'm going to break this up into Na plus, which is aqueous, and Cl minus 1, aqueous. Now, since it's 1 mole of NaCl, I can calculate how many moles of products I have. So since I have a coefficient of 1 here, I have 1 mole of Na plus and 1 mole of Cl minus 1. So if you were asked how many total moles will be produced, it will be 1 plus 1 will give you 2 total moles. Now the next one, we have CaCl2. It's a solid. Remember, water is a catalyst. You do not need to put it, but just make sure it's a catalyst, not a reactant. And that will break apart into Ca plus 2 and 2 Cl minus 1. So now, since I have a coefficient of 1, I have 1 mole of Ca plus 2, and since a coefficient of 2 for Cl minus, I'll have 2 moles of Cl minus 1. So a total of 3 moles of product. So it says write the equation for the dissolution of aluminum sulfate, and I give you the equation, or the compound. So we have Al 2 parenthesis SO4 parenthesis 3, and remember it's a solid, in water, right? Remember, water is our catalyst. So if we dissociate that, break that apart. Well, first off, it says in water, how many moles of aluminum ions and sulfate ions are produced by dissolving 1 mole of aluminum sulfate? So what is the total number of moles of ions produced by dissolving 1 mole of aluminum sulfate? So let's break this apart. So I'd have 2 Al plus 3 plus 3 SO4 minus 2. So if I added these together, I'd have 2 moles of Al plus 3 and 3 moles of SO4 minus 2. That would make 5 moles total. And one more example here to finish off this first video. So it says, write the equation for the dissolution of each of the following in water, and then determine the number of moles of each ion produced, as well as the total number of moles of ions produced. So I have ammonium chloride, so NH4Cl, remember that's a solid, and I have 1 mole. So if I break that apart, I'd have NH4 plus 1 AQ and Cl minus 1 AQ. Remember, I need to look at my coefficients, so I have 1 NH4 plus 1 and 1 Cl minus. That'll give me a total of 2 moles total. Now the next one, I have 1 mole of sodium chloride, NaCl. So now I'll break that apart into Na plus 1 AQ. Remember, AQ is aqueous, plus Cl minus 1 aqueous. 1 plus 1 we know is 2 moles. Now, here's a little trickier one. I have 0.5 moles of barium nitrate. So Ba, parenthesis, NO3, parenthesis 2. Remember, that's a solid. And it's 0.5. So we have to look at as your coefficient. So whenever you have a coefficient of 1, you're going to have 0.5. And then you'd multiply the 0.5 by whatever coefficient you have to get your number of moles. So for Ba plus 2 AQ plus 2 NO3 minus 1 AQ. So now I look. I have a coefficient of 1 here. So that means I have 0.5 moles plus I have my normal 0.5, but multiply that by 2 would give me 1. So if I added these together, I would have a total of 1.5 moles. And that concludes our video on dissociation.